Now, in general, do we feel like we are starting to get better at scheme? So would you say that each assignment kind of feels like it's at a reasonably similar difficulty, even though you pretty much know that they're harder and harder and harder? Like you kind of suck at a similar level. Okay, even though you figure if you go back 3 assignments ago, it would have been far easier to solve now. Does that kind of seem right? All right, so that's where we should be, because the whole goal here, we're kind of accidentally learning some programming language theory concepts here. I think I mentioned something along the lines of, almost like hiding medicine inside of dog food, right? When you give your dog a pill, you hide it in good tasting food, so the dog accidentally takes it, because dogs will eat anything, right? But they won't necessarily just take a pill, because that doesn't count as anything for a dog. So that's effectively what we're doing here, and then we'll see after we swing past this stuff, if we get past these exercises, then we're going to actually move into language theory stuff, and you're going to start seeing how some of these problems you've already solved directly apply to writing a programming language. All right, even though maybe they don't seem like it right now. All right, so you said 123 was the hardest, so should we do that first or last? Well, I'm not even warmed up yet. Okay. So you can sound stupid? What if I can't figure it out? Oh, all right. Let's see what it's asking first. All right. Well, that doesn't mean anything. I'm old. I'm allowed to forget things. I can just say, oh yeah, I went down this path, on purpose just to see if any of you noticed. See, teachers, we have all these get out of jail free cards. This is no problem. But when you're first starting as a teacher, then you get embarrassed when you don't know something. Then you start bringing that as a strategy into the classroom. Yeah, No. Just like, oh no, I made this mistake as on purpose to see if you notice, because I wanted to take you down a path. Now, what's funny is sometimes I do that on purpose, like actually, but then sometimes I don't. So now you don't even know which is real. That's how you keep guessing. All right, so list index. We're supposed to take a predicate. What's a predicate again? If I asked you on a quiz or something to define what a predicate is, what might you say? Go ahead.
It's like looking for a certain type of variable, like either if it's a number or a symbol.
Okay.
I'm just not sure the word I was looking for.
Okay, so I think you know what it is, but you're sucking at explaining it. Anybody want to do better than that? So she's giving me a couple of examples of what a predicate is, but
is it the one variable procedure? It takes in one variable, I know that.
Yeah, and returns what?
True
or false. Right. So a predicate is a function that takes in a single parameter and always returns true or false, whether it's met some criteria. Is it a number? Is it a symbol? Is it a list? Is it, pick your poison, right? So we can write our own predicates that test to see, is it an integer? Is it a float? Is it a double? Is what I'm looking at a procedure, starting to kind of push forward towards language theory stuff? Type inference engines, right? Determining whether the value we're looking at is a certain type. All right, so list index takes in a predicate as well as a list, and it returns the zero-based position of the first element of the list that satisfies the predicate. If no element in the list satisfies the predicate, then the list index returns false. Oh, okay. So we're going to go through, we're going to treat it as a flat list, right? So this is a list of elements, where each individual element in the list is going to be the parameter we pass into our predicate, correct? And what are we going to be, and what do we want to do? We want to return the zero-based index for where that predicate first returns a true or false. Or what does it say? Does we return false if it never returns true? So we're returning a number, or we're returning a Boolean, which is something that's a little bit weird to us, because typically when we think about functions, a function returns a type, correct? So you might have a function that returns a number. Well, this is a function that returns a number most of the time. But in the case where it doesn't return a number, it is going to return a false. Now, what does this function kind of remind us of? What's it related to in our Java world? Go ahead.
Index of?
Yeah, index of. It should kind of remind us of index of, which what returns the position of the first occurrence of some character or some substring, or what does index of return otherwise? -1. So this dude returns false instead of the -1. Make sense? Okay. So a couple different ways we're going to approach this. The first way we're going to do this is we're going to write our helper function. Okay? And what our helper function is going to do is it's going to build up a, well, we can write two different helper functions. Let's write the helper function that goes through our list one bucket at a time, but keeps track of where we are. That's the piece we're missing initially, right? What bucket am I currently in? So we'll come in here. Is that big enough? Can we read that? Okay. So we will define, what's it called, list ref? List index, like that, to be a lambda that takes in a predicate. What's a lambda again? Unnamed function. Yeah, I keep forgetting. And a list. See, you're not sure whether I'm. All right. So, and now I'm going to go ahead and call this guy list index helper. All right. And this guy is going to take in 3 parameters: a predicate, a list, and let's call it a pause. Okay. Now we're going to ask the question, if the list is the empty list, kind of a common pattern we run into, if we're out of crap to check and we're still alive here, what am I going to return? False. All right. So if null LST, what is null? What's the most generic way you could describe null to me? Go ahead. It tests to see if something is empty in this list, but what's the most generic way you could describe null to me? Based on a conversation we had about a minute and a half ago. Is null a predicate? That's what it is, right? It's a predicate. Now, predicates typically have those question marks at the end of it as naming conventions, right? Okay, so this is an example of a predicate. We are testing whether list is one of these things, in this case, whether it's an empty list. All right, if null is the empty list, then we're going to go ahead and boil down to false. Okay, we're out of stuff. Otherwise, if we're in the else, what do we want to do? Well, we want to check to see what our predicate, when applied to the car of lists, gives us. So if pred car LST, if that guy is true, I probably want to return the current index, right? So I'll return pause. If it's false, I need to keep cooking. So if it's false, I'm going to call list index helper, passing it my same predicate, passing it the cooter of my list, so everything else in my list, and then passing it pause plus 1, 1 greater than my pause. Then we'll define list index to be a lambda that takes in a predicate and a list. And this guy we'll call list index helper, passing it the predicate, the list, and a starting position of 0. Something like that. All right, so let's walk through this. So first of all, forget about the logic at this point. Do you kind of see what I did here? What we were missing in our pattern from the beginning thing so they said write a function called list index that only takes 2 parameters, right? And in our mind we're like, well, I need that third parameter. Okay, I need that dude to tell me where I am in the list. Make sense? So we just wrote a helper function that took in the 3 parameters. This really is the answer to the question, right? That guy up here. All this dude does is he gets the ball rolling by calling my helper starting with a 0. To make it easy for people to call it, I guess. Okay, so when we first call list index helper, we're going to pass it the predicate, we're going to pass it our list of stuff, and it's going to get called in with a current position of 0. We are looking at element 0 of our list. That's the guy we're currently staring at. All right, then we're going to ask the question, are we out of crap to check? If we're still kicking and we're out of stuff to check, the only reason I'm still here is because I haven't found anything that the predicate, when applied to, returns true. So that's our end case, false. Didn't find anything that the predicate was true. And this is supposed to return the position where the predicate first returns true, correct? Okay, yeah, that's what we solved. All right, so if I'm in this if here, this is the else to this first if. If I'm in this if here, that means that I have something in my list. So that means I can legally call the car of the list, right? So I'm going to say if, when I take my predicate and I apply it to the car of the list. So part of the language the book's going to use, it's going to say, here is a function named predicate. Now we know that's a variable name, right? Pred is a variable name, and it's going to resolve to its value. What's the value of that variable? Okay, what will that value look like? What kind of value is it? Cat, dog, int, char, ... I haven't given you the right answer yet. What kind of value does predicate hold? What kind of value does predicate resolve to? That's potentially a Boolean will be what the answer of predicate resolves. But pred itself is a variable name that has an associated value. What kind of value is associated with the variable name pred? Okay, now we're just guessing. Huh? A function, or what's the more generic way of saying a function? It's a lambda, right? So pred holds a lambda expression, which is an unnamed function that we named by calling it pred. That makes sense? So when this guy gets resolved, when our variable resolution happens at runtime, just like it does in Java, it's going to look at pred here and say, oh, that's a variable. It's going to go and look up. That could be kind of where the pointer thing is, right? It's going to go and look up, what's the value where pred points? It's going to kind of peek in that box and say, I see a lambda in there. That's going to tell us this guy's a function. Now we got to ask ourselves, what do we do with functions? Why do we have functions? Just for fun, just make programming harder? I mean, by now we should all find programming trivial, right? We all love programming in here. Like 2.5 people want to raise their hands, but like so far, how many people actually believe this is the most horrible class ever? I mean, it should be fun in class, but especially like when I solve it, like you said, this thing was so hard, and it's like, what the heck? Spent 3 days on that, and it's not done. Oh, okay. Doesn't it color code the parentheses stuff? I haven't even tested this yet, so this could be wrong, but I usually don't have to test my code. I'm still waiting for my first syntax error. So we have a lambda expression. What do we do with lambda expressions? We apply it to a collection of parameters, right? So this guy right here is going to resolve to a lambda. I'm taking that lambda, I'm going to say, I'm going to take this, I'm going to apply it to this one parameter, right? What's the one parameter? It's the first element of my list, the car of the list, okay? And then that guy, when I apply the function, this lambda, to this parameter, I'm going to get the result, the returned value, okay? The value that the function boils down to when I send the parameters in. Okay, in this case, that's either going to be a what? And how do you know? What kind of value will I get when I apply the lambda that's stored inside of pred to the car of the list? Boolean true or false. Why? How do you know that? No, we're passing whatever the list is. That could be a number, that could be a cat, that could be a dog, it could be a list. Because that's what?
Because that's what the predicate returns because it checks if that is what the predicate.
Because that's what predicates are.
Yeah.
Predicates are single parameter functions that return booleans, true or false, right? So either we've used a misleading variable name here, or in fact this guy is a predicate, therefore predicates return trues and falses. So this guy right here, when all is said and done, is going to boil down to a value of true or false. And what kind of thing boils down to a single value of true or false? Boolean expression. And when do we use Boolean expressions? In if statements and for loops, and we have an if statement right here. So if this Boolean expression I have highlighted here returns true, what are we going to return? The current position, where we are in the list, because we just found a place where this predicate, when applied to this parameter, gave me a true value. Make sense? Now, if it didn't give me a true value, then I'm going to be in the else here. And we're going to say, look, we're not done yet. So we're going to go ahead and call our helper, passing it the exact same predicate, which is a lambda. It's going to boil down to a lambda. Passing it everything in the list except for the dude I just tested. And then I'm going to go ahead and add 1 to the current pos in my list to keep track of where I am. That make sense?
I have a question about the pos in 1 there. Are you able to swap the two and it wouldn't make a difference?
Yeah, you could say add 1 pos. Because this boils down to a number. It does not change the value of pos. Let's see. Did he give us some? This is an example, right? Okay, so the first thing that should be a number here should be bucket 1, because we're going to say, is A a number? No, that's a symbol. Is 2 a number? Yes. So this is going to give us a 1. Go ahead and run this guy. There's our 1. Is it the same list? Well, let's just go with it. We'll change the predicate here to symbol. And this guy is going to symbol question mark. Now, why is the question mark here? Okay, so is that a required part of the syntax? Sort of kind of a trick question, but not. Depends on how you understood what I asked. Do all predicates have to have a name that has a question mark in it? No, it's a naming convention. If you see a function name that happens to have a question mark at the end of it, probably a predicate. Unless, again, somebody's tried to make a misleading function name. Okay, so that happens to be kind of a common way of naming predicates is by putting what you're testing for with a little question mark at the end of it. Make sense? It's not a required part of the syntax. This guy could very easily be a function called cat. Okay? So this guy's going to return 0 because the first symbol is the A. If I change this to be list, it's going to return 0, 1, 2. The first list in here was at bucket 2. Sound good? Let's take the list out. We'll just put a 3 there. This guy should give me a false because there are no lists inside of my list. So there's my false. All right, questions about that? Now let me ask you this. What would happen if I mapped that function, which takes 1 parameter, right? So map only works for functions that take 1 parameter. And I mapped it across this list. What would I get? What would my result be if I run this program right now? Go ahead. List of true and falses. What specifically would it be right now? Bunch of falses, right? Because when I apply the list predicate to an A is not a list, so it's going to give me a false. 2, not a list. 3, not a list. B not a list, 7 not a list. It's going to give me a bunch of falses. Make sense? All right. Let's go ahead and put the list back in here. I don't remember what it was, but whatever, something like that. So now we'll have that true in that one place. Something like that. Kind of see how map works. So could we have mapped across the list first to get us a whole bunch of true and falses? Then just walk through and see where we find our first true? Another possible way we could have approached this. I'm not sure that's necessarily any easier. Could we make this easier? Using map. Can we come up with a power tool here? I'm gonna give you a hint. All right, I'm only, let's call it 30%. I'm more like 98% certain this works. Plus yeah, so you can apply plus to multiple parameters. Similarly, is there a sum? Okay, there's not a sum.
Would it just be equal?
Wouldn't what be equal?
Would it just, instead of sum, would it be just the equal sign?
No. I want to take a list as a parameter and add up all the stuff that's in the list. So we could certainly write a function that does that, right? That takes a single parameter, a list of numbers, and returns and sums up all the stuff in it. So if I want to write that, so let's do this. We're going to define. I think that wasn't this actually one of the questions from earlier, or was it actually was the quiz question from was the quiz question from last class? Sum a list of numbers. This guy's going to be a lambda that takes in a list. If null list return 0, else plus car list sum cooter list. Okay, so that's sum. So now I can do sum 1, 2, 3. Oh, sorry. Sum 1, 2, 3. I'm passing it a list as a parameter, so I have to quote it. Otherwise, if you don't quote it, it tries to apply the function named 1 to the parameters 2, 3. When I put the quote in front of it, it says, this guy's a list literal. All right, so now I have a function called sum. So can we use map to solve this problem in a substantially more complex way, but let's say a shorter way? Well, I can get a whole bunch of trues and falses, right? And then I can, actually, let me think about this. Can we do it that way? Yeah, you can do it. It's actually going to be way more. I don't think it actually saves you complexity. What you can do is you can map across the list, get you a bunch of trues and falses. But instead of mapping that across there, instead of mapping the predicate, you wrap the predicate inside of another function and give yourself a list of zeros and ones. Where wherever it's a 0, it's a false. Whenever it's a 1, it's a true. Now you got to go and do a sum across there, but anything after the first 1 ends up becoming a 0. So you want to stop summing at that point. So you could end up using map twice and make this work. But you'd have to write a sum function that maybe added a -1 alternatively to get the math to work out right. So you effectively sum up your position. So realistically speaking, probably what we wrote here is already the best. But at least it showed us what we can do with map to kind of give ourselves a big predicate. Now, we could, though, write whether or not something in the list is true for the predicate. Rather than the position of it, we can use map to figure out whether something in the list matches the predicate or not. And we can do that. If I have a big list, like false, false, true, false, false, I have a list of these, and I want to know whether or not there is a true in that list. How would you do that? I have a list that looks like that, what I have highlighted. And I want to ask the question, is there one true value in that list? True or false? There is a true value in that list. As human beings, we look at that and say, yeah, right here, here's our true, right there. There's one true value in there. So I want to be able to ask, is there at least one true value in there? What function do we use to determine whether there's at least one true? We've all used it before. Or? Is that what the or function does? So false or true or false is true. Make sense? So we could write a predicate that determines whether a list of Booleans contains at least one true. Similarly, we could write a predicate that takes a list of Booleans and determines whether or not it's all true using an AND. Correct? If you want to find out if there's at least one false, you could also use an AND. Might be all falses, but if there's at least one, AND breaks. All right. Questions about any of that stuff? Hopefully we saw at least a practical example of map here, so maybe you can start thinking about how that might play into some of your solutions now. So map gave us this list. When I mapped the list predicate across this collection of elements, where only one of those elements was actually a list. And what we saw here is a list of results. The first result is what happens when I ask if that guy's a list. The second result is what happens if I ask if that guy's a list. Third one, what happens if I ask if that guy's a list, so on and so forth. That's how map works. Map takes a list and applies a single parameter function to every element in that list. Not necessarily a predicate, but a single parameter function. Because not all single parameter functions are predicates, right? Because predicates specifically return true or false. All right. Next question. 1, 2, 4. Every returns false if any element in the list fails to... Oh, here we go. I promise I did not look at that yet. I did look at it last week, but I'm old, so I forgot about it. Every. So this guy takes a predicate and a list and returns false if any element in the list fails to satisfy the predicate, and returns true otherwise. Let me test something here real quick. Or okay. Now we got to do our mathy thing. Okay. So every returns false if any element of the list fails to satisfy the predicate. Okay. So we'll define every to be a lambda that takes a predicate and a list. And this guy should return true if every element in the list is true when the predicate is applied to it, right? So let's write it the straightforward way first. So we'll ask the question if null list, we can go ahead and return true. Because what we're going to do is we're going to link a whole bunch of ands together here for the every. All right. So if I'm out of stuff, at the very least, I can't say that there was nothing before me. So I'm just going to go ahead and finish with a true. Otherwise, if there's something in here, I'm going to ask the question: if pred, when applied to the car of the lists, if that guy is true, then I'm just going to call every, passing it the same pred and the cooler of the list. Pass up that guy, we're still good. That guy is false, we're going to go ahead and return false. With that, we actually didn't need to link a bunch of adds. So if I'm out of stuff to check and I'm still kicking, that means I didn't find something that failed the predicate. So go ahead and return true. Everything in it matched. Otherwise, if when I apply the predicate to the first element of the list, it's true, we would just say so far, so good. And we'll go ahead and call every on everything else in the list. Keep trucking. Otherwise, if we found the one thing that failed, well, if one thing fails, at the very least we know that everything wasn't true. Therefore, go ahead and return false. Does that make sense for every? Okay. And you want to test this guy. So are all these things numbers? They are not, so this guy should return false. So there's our false. If I change this guy to a R and I'm checking for symbols, all of those guys are symbols, so we will return true. That makes sense for every? Yeah, and you actually you can use map for this one, but it would be you would just be showing off, and it wouldn't be any simpler because the solution to this was actually pretty easy. Because what you'd have to do is you'd have to do that conversion from a Boolean false to a maybe you do a Boolean false to a 1 and a Boolean true to a 0, and then you'd sum up every element in the list, and if you have anything greater than a 0, that means there was something in there that broke it. So you would do it with math, and then you would use the sum function finally on it and get your answer, and then you would map that to either true or false. Okay, so then next one is exists, returns true if any element of the list satisfies the predicate or returns false otherwise. Define exists to be a lambda that takes in a predicate and a list if null LST return false. Because as far as I know, the fact that I'm still here means that you didn't find any truths before me. So I'm certainly not going to make it true because I had nothing to look at. So I'm going to return false. Otherwise, I must have had something. So if pred, when applied to the car of LST, if that guy is true, boil down to true. I found one. Right? There might be more than one, but I only need to return true if I found at least one. If it existed. If something in the list, when that predicate is applied to it, returns true. So right here, found something, return true. Otherwise, let's keep trucking. We'll call exists on the coder of the list. Make sense? So here's our, actually let's do exists number. We'll change this R back to a 3. So even though this list is primarily symbols, there is one number in there. That means this guy should boil down to true.
You're just passing the predicate.
Oh. I did.
Question mark.
Oh, not passing the predicate. I called the function I haven't written yet. Right? My name of my function I called is called exists here, yet the name of my function I wrote is called exists with a question mark on it. So I have to call the right function.
Only call it recursively too in the function. Passing the predicate.
I see what you're saying. There we go. Did it on purpose. Teaching point, yeah. Okay, so there's my true for that one. If I change this back to an R, then there is not a number that exists there, so this should be false. Make sense? Man, those last two were not 2-star questions. Really, the first one wasn't a 2-star question. The first one was a 1-star question. The other two were 0-star questions. Go ahead.
So 1.2 and 1.25 are like exactly the same, but like opposite, like looking for the opposite thing. So like one of them was just looking for all of them had to be the same thing.
Yep.
whereas one-
Correct. All right, so let's see. So let's look at this next one, 1.26 up. So this one, I don't want to solve any hard ones in class. I want those to be homework. Oh yeah, we'll definitely do this one for, oh yeah. All right, so up says remove a pair of parentheses from each top level element of list. If a top level element is not a list, it is included in the result as is. Okay. So, for example, if I call up on the list containing the list 1, 2, this element should get those parentheses removed, leaving us with a 1, 2. This element should give us the parentheses removed, leaving us the 3, 4. So there's our 1, 2, 3, 4. We removed the parentheses from around those guys. All right. If I do up on X, so the first element here is the list containing X and the list containing Y. This guy here should boil down to X and then the list Y. But Z, since it's not already in a list, is left alone. It's just by itself. All right, so how do we solve up? Let's look at the simple case first. I have a list 1, 2. Here, you want me to put all this stuff in Slack? I always got to remember, I got to leave Slack on this computer at a screen that wasn't like from a possibly inappropriate conversation, like this guy. Okay, We are not clicking on that guy in class. I have no idea what's new in there, but I can give you about an 85% chance it's not good. It's not good. All right, so let's say, let me delete all this. Let's say that I have, what was it? The semicolon was the, so let's say I have the list 1, 2, and I want that guy to turn into, this is actually the list containing the list 1, 2. And I want to turn that into the list 1, 2. Like that. Hence, remove a set of parentheses from that inner element. So how do I take this element, which is a list containing 1, 2, and remove the parentheses from it? At the end of the day, I'm building a brand new list here, right? Okay, so I'm building a brand new list. Here's the first element of that list that I'm building. This guy happens to be a list. So I need to now process through that list and add each individual element of that list, cons, each individual element of that list to my running total. So we're going to say define up to be a lambda that takes a list as a parameter. Then we're going to ask the question if null LST, return our empty list. Pretty common pattern. All right. Otherwise, I know I have a car. But I need to know whether the car is a list or not. So now I'm going to ask the question if list car LST if the car of the list is a list, I need to do some processing. So I'm just going to do this for right now. Process. Else, I'm going to cons the car of the list onto up of the cooter of the list. Because I didn't need to do anything special. If the first element was not a list, there's no parentheses to remove, we leave it alone. So the magic that has to occur is right here. If the first element of the list is a list, I need to process it, which means I need to give myself the elements of that list with one set of parentheses removed. Go ahead.
Clear of the list or clear of the LST?
Oh, thank you. Cooter of LST. See, I was testing, you passed. So now, if I'm looking at something, so if the car of LST is a list, so if it looks something like that, and I want to add that to my growing list, but I don't want to add it as a list. I want to add it as a 1, 2. How do I do that? Go ahead.
Can't you just do the same thing as below instead of car is the car of the car?
That will only give me the first element, not the entirety of the inner list. The car of the car would give me this 1. What about the 2? Make sense? Huh? A helper function? You can do that? And what's the helper function going to do for me?
Well, you can pass the whole list.
Okay, so you want to pass the helper function to list 1, 2.
Yeah.
And what do you want it to return? I can do this in one line. When I say that, does anybody, just raise your hand if you think you know. Does anybody think they know the answer? I got a half a hand. What do you think? Map function? You think map? Okay. What do you think?
Isn't there an append function?
There is an append function. What does the append function do? So what would happen if I appended the list 1, 2 onto the empty list? I get a flattened list. So I will append the car of LST onto the up of cooter LST. Like that. Make sense? So I'll give that to you as an example. I'm sure, do we want to test it? Maybe test it. I rarely write anything that's wrong, so it's, especially since she fixed my obvious on-purpose mistake. So we don't have to worry about that one. So this guy should give me just the list 1, 2, 3, 4. Oh no. Oh. See, another on purpose, clearly on purpose mistake. Cooter is a function. I didn't put a parenthesis before it. There's my list 1, 2, 3, 4. All right, so I'll go ahead and paste this into Slack as well. And then let's go ahead and, whatever, that's good enough. Let's look at our assignment, and I'll actually put it up on Blackboard right now too, which is good because then I can put more stuff. I'll give more assignments since I'm putting more stuff in there. I'm putting it up early. What class is this? 470? All right, so how many questions should we have for Wednesday? Definitely need to have harder ones than we had today, right? Scheme homework 6.
Give us one really hard one.
So I should have just given you the one we just did. See how long you guys spun on that one? That would have been great. All right, so let's look at this. So we definitely got to do 1, 2, 7. That's it? Oh, no, that's cowardly. Oh, no, merge. This one's a nightmare. 1, 2, 8. Got to do that one.
All right, that's good. That's all we need right there.
Oh, we got a minute left in class. Hold on.
Can we take a vote on the homework?
Let's see, returns a list of elements. Ways of ascending. Oh. Oh. Oh, my goodness.
My spirit.
My gosh.
It's like a weekend assignment. Could it be done Friday?
Oh, this one is ridiculous. All right. But I'm going to also put up the new Bible verse. I'm going to put up the new Bible verse. That's due Friday. So, but just be prepared. You're going to have these two to do for Friday. And these guys are ridiculous. So these two assignments should take you a minimum of maybe 60 or 70 hours each to come up with like the right 4 lines of code. Okay, and you cannot use the built-in sort function. I'll tell you that right off the bat, because then it becomes very easy. You just put sort out front. Done. All right. So I'll put up the new Bible verse here in a few minutes. Otherwise, I will see everybody on Wednesday. So 127, 128 for next class. You guys are just cowardly. Maybe I should give you all 4 for Wednesday. No, that's just cruel. For those of you who want to start early, you might want to start working on those next 2 for Friday, like already. What's up?
So I was gone last Friday for football, and I seen you